All right, so this session is now being recorded. If you can all go on mute, please. You can unmute yourselves whenever you have any questions or any inputs to share. So these are the four topics in this chapter. We did trigonometric ratios yesterday and trigonometric ratios of select angles. And then these are the remaining two that we will complete, and then we will solve as many numericals as we can, in the time that we are left with. Now, if you can all recall, very quick recap of what all what all trigonometric ratios are. We have sine theta, cos theta, and this is the reference triangle that we are making, we are using. This is the triangle that we are referring to. This is a right triangle where you can see with reference to the acute angle, which we are referring to as theta here, the opposite side is called the perpendicular, adjacent side is base, and the hypotenuse is anyway hypotenuse, right? So we know, we just learned something yesterday, a mnemonic, call it. Some people have curly brown hair turning permanently black. So this is how we have all the three trigonometric ratios, and these are the respective reciprocals. So I hope you're clear with this. Then we came to the trigonometric ratios of select angles, 0, 30, 45, 60, and 90. So I'm just going to tell you a technique by which you can remember all of these. We discussed some technique yesterday, but there is something more to it that I'm going to tell you. And then we will move on to topic 3 and 4. We'll wind up in probably 20 to 30 minutes. And in the remaining 30 to 40 minutes, depending on how much time we have, we will be doing a lot of, or as many numericals as we can. Are we good to go now? Any question about any of the things that we discussed yesterday? Anyone? Or are we good with everything that we discussed yesterday? All right. So let us have this technique of remembering. Okay. And this is, please be on mute, all of you. Who is not talking? One of these guest users is not on mute. Can you please mute yourself, please?
ఇప్పుడే స్టార్ట్ అయిందని అన్ని చెప్తుంటే స్టార్ట్ అయినప్పుడు అది చెప్పుడే వినాలి మరి వింటున్నా అక్క ఈ రూమ్ లో రాగానే బయటకు.
Okay, so look, this is not given in your textbook. This is a way by which you can remember these values very easily. So what I do is, starting from 0, write 0, 1, 2, 3, 4. This is for sine theta. I'm just telling you a technique by which you can remember these values. 0, 1, 2, 3, 4. Divide this by 4. Divide every number by 4. So what all have we done so far? We wrote 0, 1, 2, 3, 4 and divided every number by 4 and take their square roots. Now, can you tell me how much this one comes to? The first one.
0.
0. All right. So I'm just writing here for now so that I can, if I erase, probably you'll miss out on what. So for now, I'm just writing this value of sine theta here. Okay. 0. 1 by 4. What do you think it will come to? 1 by 2. You agree?
Root 1 by 2.
Yeah. Root 1 is 1, right? So 1 by 2. This becomes 1 by 2. And if you remove the square root, it becomes 1 by root 2. You agree? This is root 3, and the 4, comes out of the square root cap. You are left with root 3 here and divided by 2. And this is 4 by 4. So this is 1. You all get it? This is how you can remember these values. Okay. And once you get these values, I told you yesterday that cos theta is just the ulta. 1. This is root 3 by 2. This is 1 by root 2. 1 by 2. And 0, and tan theta is sine theta by cos theta, 1 by root 3, 1, root 3, not defined. So this is how you can remember these values. Again, I tell you, this is not given in your book, and it might be worth remembering, noting, do whatever, but just note this technique of remembering the values of sine. And then once you get sine, cos is just the ulta, and tan is sine theta by cos theta. So as in effect, you don't have to memorize any value. All values can come from this technique. If you are good with this, we'll move on to the third topic for today. Good, all of you. Shall we move on? Take a screenshot if you want to refer to it, so that we save time. Take a screenshot, one of you, and not everybody has to take screenshots. Take a screenshot and we'll move on. All right. So we now move on to trigonometric ratios of complementary angles. See, uh, again, a very easy topic if you are attentive, and it gets impossible if you are not attentive. It's just one or zero. In these chapters, it's just one or zero. You either understand or you don't understand. Understanding is easy, and not understanding is equally easy. It's the attention that makes the difference. How much attention you give me in the next 5 minutes will determine how comfortable you get with this topic. That's it. Nothing more, nothing less. Now, what we are doing is we are referring to one. Let's make use of this particular triangle. So tell me, if this is 90 and this is theta, how much will this be in terms of 90 and theta?
90 minus theta.
Very good. So this is 90 minus theta. I hope you all agree. This is 90 minus theta. Now let's define all the trigonometric ratios with respect to this triangle that we learned yesterday. So first one, sine theta. Sine theta is how much in this case? You agree it's perpendicular by hypotenuse, all of you? Yes. Cos theta is equal to, so we are talking about the theta first, okay? All 6 trigonometric ratios in terms of, not in terms of really, when the reference angle is theta. So what happens when we take cos theta? It is based by hypotenuse, and tan theta is equal to perpendicular by base. What other trigonometric ratios do we have? Sin theta ka reciprocal is cosec theta, cos theta, reciprocal of cos theta is sec theta, and then we have cot theta. Cosec theta is how much? It's just a reciprocal, so it's h by p, h by b, and b by h. Any problem so far? Just call out in case there is anything that you don't understand. This class is not just for attending. I'm telling you, I have been telling you again and again. If you're attending this, you must get it. Let us
Cot theta is b by h or b by p?
B by P. Very good. Thank you. It will be B by P. Yes, all of you. No problem so far. Now, this was when theta was the reference angle. I hope you can see this part of the board. Let me know if some part is not visible to you. Now, if we take 90 minus theta as the reference angle, let us now define all of these when 90 minus theta is the reference. So what do we get? Sine of 90 minus theta. Yes, come on, tell me quickly so that I have a ready-made thing to write here. Sine of 90 minus theta. Yeah, go ahead, tell me. I'm waiting for you to tell me sine of 90 minus theta.
So we just said you have to use the same letters you wrote on the.
Any sine of 90 minus theta is how much, man? This is the reference angle. So in terms of this reference angle, what is sine of 90 minus theta? Which one is the opposite side? Perpendicular is which one here in this case?
BC.
BC means B, right?
Yeah.
B by H, you agree?
Yes, sir.
Cos of 90 minus theta?
P by h.
P by H, very good. tan of 90 minus theta is opposite side by adjacent side. So it's opposite side by adjacent side. You agree? It's B by P. Cosec of 90 minus theta will be, cosec is the reciprocal of sine. So it's H by B. Then we have sec of 90 minus theta. And that is H by P. And finally, cot of 90 minus theta is equal to P by B. Two things. Have you all understood what we have done? Don't think anything beyond. John, I'll tell you what you are to do. You don't have to think beyond. Just confirm that you have understood this much. And if I have made any mistake somewhere, just call out and I will correct that. So it's something like this. Let's say I'm a storyteller and you people are listening to the story. Don't think beyond what I have already told you. So far in this story, I have told you only up until this. What I may tell you, don't run or break your head over it. I will tell you. I will tell you. For now, just confirm if you have understood these two columns 100%, all of you.
Yes, sir.
Yes, sir.
Perfect. Perfect. Now see what will happen. So if you want, you can take a screenshot here because I'm going to erase this, this triangle now, because I have already put all the information from this triangle that I require. I don't need this triangle anyway, and I don't have board space, so I'm going to erase this. Take a screenshot if you want. I hope you have taken one. So now I'm removing this. Let's see what all. Now comes match column A with match column B. Do you see that sine theta? We're just doing the matching for now. Which one is B by H? This one. Then is P by B. Where is P by B?
Cot.
Cosec. H by P. Where do we have H by P? H by B. And B by P. I'm just writing what all I have matched. So I see that sine of theta is equal to cos of 90 minus theta. Yes or no, all of you? Cos of theta is sine of 90 minus theta. Tan of theta is equal to cot of 90 minus theta. Cosec of theta is equal to sec of 90 minus theta. Sec theta is equal to cosec of 90 minus theta. And cot theta is equal to, cot theta is what? Tan of 90 minus theta. Now, this is what the trigonometric ratio of complementary angles is all about for any value of theta. And we are talking about right triangles only. I told you yesterday, class 10 trigonometry is confined only to right triangles. So in any right triangle, for any value of theta, and theta is an acute angle, for any value of theta, wherever it is, whatever it is, this will always hold good. And this is something that you need to remember. We will see how to apply these learning in our examples, which we will do shortly. But before you copy, are you people 100% good, comfortable with this? Have you understood? It's not just about memorizing, mind you. It's about understanding. That's very important. Your memory might fail, but your understanding will never fail. That's a key that I want to stress upon. I have been doing that. Memory may fail, understanding never does. So have you people understood this?
It's clear, sir.
Perfect. Copy this down and let me know, or take a screenshot, whatever you want, and tell me once we are good to move on to the next topic. Are we good to go on to the next topic, all of you?
Yes, sir.
Perfect. So that's trigonometric identities. Now, can somebody tell me what you mean by identities? Identities. You have done identities in the past, not trigonometric identities, some other identities, but you know what identities mean. So see, are you familiar with the formula a plus b the whole square? That's equal to a square plus b square plus 2ab. Yeah. Or a square minus b square is equal to a minus b into a plus b. Now, what are these? These are identities. What does it mean? That for any value of a and b, this relation or this equation or this formula holds good. A square plus b square plus 2ab for any value of a, for any integer value of a and b, this relation always holds good. Here we are talking about trigonometry. We talk about in terms of the acute angle theta. So for any value of theta, these relations will hold good. That's what trigonometric identities are. And we'll see how we derive this. Again, I have been insisting on understanding. Memories may fail, understanding never does. So again, I'm going to just derive three formulas or three identities. The advantage of doing it this way is that even if you forget a formula sometime, you can always derive it. That's how it will help you. Now, I am again drawing a triangle. Let's call it ABC. This is our reference angle theta. And let's give them a name, so in terms of, or we can let's give them a name, so this is okay. Let's do it in terms of what we have been referencing so far. This is p and this is h. Instead of bringing in new variables which might confuse you, I'm just using the same thing. Now, by Pythagoras theorem in triangle ABC, by Pythagoras theorem, you agree that h square is equal to b square by b square. Yes, this is our equation. I'm just writing this 3 times. I'll tell you why. H square is equal to b square plus b square, or h square. Or let us rather, if in case this gets confusing, as to which one is p and which one is b, let us go by the Pythagoras theorem that we have been familiar with so far, which we learned in class 7. AC square is equal to AB square plus BC square. You all agree? Now I'm just writing it 3 times. I'll tell you why. Because there are 3 identities that we are going to derive. I'm just writing the same thing 3 times. Now if I divide this equation, divide by AC square. So what we are going to do is we are just going to do a simple thing. We are going to divide this entire equation by AC square first. And then we are going to divide by AB square. And then in the third case, we are going to divide by AC square. So can you tell me what will the result be if we divide this entire equation by AC square? You agree that this will become AC square by AC square is equal to AB square by AC square plus BC square by AC square. This becomes 1. That implies 1. And now can you tell me AB by AC means what? AB by AC, is it not sine theta? Hey, making sense? Following? Can you tell me what BC by AC is? BC by AC is what? It's base by hypotenuse. So what is base by hypotenuse?
Cos theta.
Cos theta the whole square. So that comes to cos square theta. Now this is an identity. Therefore, if you square this, it is written as I told you yesterday, sine theta square is written as sine square theta plus cos square theta is equal to 1. This is one identity. There are 3 identities in all. This is one of them. Make sense, all of you? Sine square theta plus cos square theta is equal to 1. for any value of theta. That's it. Let's come to the second one. Now let's divide this by AB square. Dividing this entire equation by AB square. So what do we get? AC square by AB square is equal to AB square by AB square plus BC square by AB square. Now this becomes 1. Now can you people tell me quickly what AC by AB will be? AC by AB is hypotenuse by perpendicular. What is hypotenuse by perpendicular? Perpendicular by hypotenuse is sine theta. So hypotenuse by perpendicular is cosec theta. So I'm just writing in one step. Okay, this is cosec square theta is equal to 1. And can you tell me what BC by AB? BC, so it's adjacent side by perpendicular. So reciprocal of what?
Cot.
Cot. Very good. So this is another identity. 1 plus cot square theta is equal to cosec square theta. I'm going to summarize all over there once I'm done with all derivations, and then quickly divide this by. So we are done with the first two. We are dividing this by BC square. So AC implies what? AC by BC the whole square, it will be, is equal to AB by BC plus 1. So AC by BC. AC by BC. Hypotenuse by base. Base by hypotenuse is cos theta. Hypotenuse by base is its reciprocal, sec theta. It's called sec square theta. You get sec square theta is equal to 1 plus tan square theta. This is the third identity. So I'm just erasing this. Now we are done with all of these. So I can use this board space to just summarize all the results that we have just derived. So what do we get? The first identity, cos square theta plus sine square theta is equal to 1. This is for any value of theta, mind you. 2, 1 plus cot square theta is equal to cosec square theta. True for any value of theta. 1 plus tan square theta is equal to sec square theta. These are the three identities that you ought to know, and that's it, nothing else. So let me know if you have understood, not understood. Copy this down, take a screenshot, whatever. And as we had anticipated, we are done in 25 minutes around, and we will now use the remaining time to solve as many numericals as we can. Let me know when we can move on from here. Yeah, shall we move on, all of you? Are we good?
Yes, sir.
All right. Okay, so when I say we will be solving numericals, I will wait. I will look upon your participation. Okay, so now I am just going to We are going to solve this, okay? Not I. We are going to solve this. So let's see how much you remember. I know there will be some, stuffs which you will obviously need practice to remember. There are a lot of, there is a ratio, there are ratios and then identities and complementary angles and what all. Before that, I'll tell you one cool fact. Don't look at it from the trigonometric lens. This is common, just this is generic. So if I tell you that there is a 30, 60, 90 triangle, what can you tell me? Can one of you or more of you, many more than one, whatever, whoever, tell me what this means? I tell you that there is a 30, 60, 90 triangle. What does this mean?
A right angle triangle where
Okay,
theta
sir.
can be 30 or 60.
Perfect. So that is a right triangle because 90 degrees is what we have. The remaining two acute angles, obviously the two remaining angles are acute angles. I hope you know that. Are what? 30 and 60. So this is 30 and this is 60. Okay. Now, again, let's take the same triangle for our reference ABC. And we'll call this side A. We'll call this side B. And we'll call this side C. These are the measures, let's say. Now, what is it? It's a 30, 60, 90 triangle. Now, whenever you have a triangle in which the three angles are different, I hope you all agree that this is a scalene triangle. What is a scalene triangle? Where all three sides are different. It is not an isosceles. It is definitely not an equilateral triangle. This is a triangle where all three sides are different. You agree? A, B, and C will measure differently. And can somebody tell me which side is the longest side in this triangle, in this particular triangle? The hypotenuse. The hypotenuse in a right triangle is always the longest side. And in this particular triangle, which side is the shortest side?
It's A.
It's A. And why is it? The side opposite to the smallest angle in a triangle is the shortest side. The side opposite to the largest angle is the longest side. So in this case, even that way, you can see that this is 90. This is the largest angle. And therefore, the hypotenuse in this case is the longest. It always will be. And in this case, 30 is the smallest angle. So A is the smallest. Now, in this case, you will see something interesting. B is equal to 2A. This holds good every time. So when it's a 30, 60, 90 triangle, the hypotenuse measures twice the shortest side. How can we prove it? How much is this? If I take sine of 30, sine of 30 is equal to how much in this triangle? Can you tell me? Sine of 30 is opposite side by hypotenuse, perpendicular by hypotenuse, A by B. What is the value of sine theta? From the table that we drew, you might not remember, some of you might. Sine 30 is 1 by 2. That is equal to A by B. And therefore, B is equal to 2A. You can derive it this way. But the result is this. No matter what kind of a right triangle, it doesn't only have to be in trigonometry, obviously. Right triangles are not the patents of trigonometry for that matter. So if it's a 30, 60, 90 triangle, summary, the hypotenuse measures twice the longest side. That's a cool fact, which you will use many and many times in the geometry section of class 10 geometry. All right, now let's move on to solving some numericals. All right, so I've just noted some numericals which we'll very quickly solve. Can you tell me if this is true or false? Very quickly. A, sine of A plus B is equal to sine A plus sine B. What do you think? How do we prove?
It's false.
How? It's false. Okay. How do we check this? How do we check this? See, if I take, it's about substituting the values. If I take A is 0 and B is 90, let's say, then what is our LHS? LHS is what? Sine of 0 plus 90, that is equal to sine 90, and that is equal to 1. You all agree? Sine 90 is 1. Now, if I substitute a is equal to 0, what is sine of a? Sine of 0 plus sine of 90. So this is 0, this is 1, and this becomes 1. It's the same, but this is only for one set of values. Generic, whether it's true or not, you'll have to check for a couple more. You'll have to check for a couple more maybe. And if you are getting this true for every A and B values, only then you can conclude. But this is not enough. We will try some more. Let's take both A and B as 45. Okay. So sine of A plus B, then A is equal to 45 degree and B is also equal to 45 degrees. So LHS becomes sine 90, and that is equal to 1. How about the RHS? This is sine of 45 plus sine of 45. This is equal to 1 by root 2 plus 1 by root 2 is equal to 2 by root 2 is equal to root 2. So this is not true. What is the conclusion? This may or may not be true. If it is a true and false, it is a false statement. You get it? All of you. So it's just not enough to conclude based on one set of values. You'll have to check for a couple of them. If you are getting the same thing even here, then you could have concluded, but just on the basis of one set of values, that might be a premature conclusion. All right, all of you. So be careful. That's the message. Now, value of sine theta increases as theta increases. That's the second one. Well, write the next two statements together and we will analyze both. A, value of sine theta increases as theta increases. If it's true or false, tell me. Value of cos theta increases as theta increases. So it does someone do you remember the values of sine theta and cos theta for various values? 0, 30, 45, 60, 90. You'll see sine theta is how much? 0, 1 by 2, it's 1 by root 2, it's root 3 by 2, and it's 1. So you'd see that, yes, indeed, as theta increases from 0 to 90, sine theta indeed increases. So sine theta increases as theta increases. What is the conclusion? Is it true or false?
It's true.
It's true. And we also know that cos theta is just the ulta. Obviously, value of cos theta must be decreasing, right? That's a true statement. Increases as theta increases. That's false. You are with me, all of you? This is true, this is false. All right.
Yes, sir.
And just one thing. See, we have found the value of sine theta for specific angles. Only this much is in scope for class 10. But very important, sine of theta has a value for every value. Sine 29 has a value. Sine 31 has a value. Sine 33 has a value. Sine 84 has a value. Sine everything has a value. It's just that it is not in scope of class 10 mathematics. Get that right, okay? So sine 89 also has a value. Sine 76 also has a value. But we ought to remember only this much, thankfully. All right, so next one. Sine theta is equal to cos theta for all values of theta. I think it's a very, very easy question, isn't it? Sine theta is equal to cos theta for all values of theta. Is that right or wrong?
Wrong.
There is only one value of theta for which these two values are the same. Can you tell me? Part A. Hey, sine theta and cos theta are equal only for one value of theta. What is that value of theta and what is the value of sine theta and cos theta? See, sine 45 is 1 by root 2 and cos 45 is also 1 by root 2. Okay, So sine theta and cos theta are equal only when theta is equal to 45 degrees. So this statement is false. Cot A is not defined for A is equal to 0. Let's see how much is cot A. Let's derive. Cot A is equal to cos A by sine A. Cos A is 0. Sorry, cos of 0. So this is equal to what? Cos 0 by sine 0. Cos of 0 is 1. Sine of 0 is 0. So this is actually not defined. That's right, right? Cot A is not defined for A is equal to 0. So this is how, this is not about memorizing as you have seen. This is about solving, resolving rather, and then concluding. Let me know from 1 to 5. There are 5 things that we quickly solve, true and false, if you people are all very comfortable with what all we did now. Hey, are you people following? Are you having fun? It's about enjoying, please. You know, I think it's not, don't take this as a class on Sunday or whatever. No, I think it's a mindset that counts. I hope you people are enjoying. I hope
Yes,
people are
sir.
understanding new things. I hope this will help you going forward. So, you know, this, I think we have to keep the tempo. It's not about working very hard, I tell you. No, it's about keeping the tempo. It's about being in the right frame of mind. It's about enjoying. It's about identifying what all you are not enjoying and just seeing to it what needs to be done, because you don't have a choice. Let's see, you know, let's be brutal sometimes, you know, to get things right. It's not enough to say that I don't like geometry. Hey, what statement is that? That doesn't help you. It's about finding out ways to, the fact is that we are in denial. We say I don't like geometry. Why? Because I don't understand geometry. That's the problem. Why would I not like it? It's because, and when my friend says that, hey, I too don't like geometry, we become very good friends. It's such a boring subject. No, it's not a boring subject. You are not understanding it. That's why you are finding it boring. Let us be blunt. Let us be brutal sometimes. You know, it's only then when we counter, when we what is that? When we confront contradictions and conflicts, that we get the better out of it. Just being in denial will not help. Okay, enough of Gyan. But I hope you are with me. All right, next is the next few numericals. We have 20 more minutes, and we will definitely solve some more very interesting numericals as I see. Let's see. Okay, now what is, see, whenever you see a numerical, some of the 4 topics that we discussed and the numerous formulae and the identities that we discussed, you know, it's about the right tool at the right time. Hey, please go on mute. Somebody else can mute him, you know, whoever is not on mute, there's some noise. Cos of A minus 26. Find A. So before you see this question, just listen. You have a few tools. We have a few tools at our home. We have a plier, we have scissors, we have hammer, we have screwdriver. Now, which tool is best suited when it comes to hair cutting? Hammer or screwdriver or scissors? It's scissors. So what do we mean? It's about the right tool for the right job. We don't use a hammer to cut our hair or bang our head, right? Do we know hammer is the right tool, but for something else, if it is used at a wrong place, it becomes an incorrect tool. What I'm trying to come to is that we have to identify what this is. Is it hair cutting? Scissors. Is it a nail? Hammer. What I'm trying to say is, looking at this, you have to identify the right tool. So tell me, what tool will help, might help here? All right, let's take one step back. I said Monu has rupees 200 and Sonu has $2. Which one is better? If we really don't know the conversion rate, then you cannot conclude. Am I right? If you don't know what $1 is equal to in terms of rupees, you can't make out. Is that making sense? You have to know the conversion factor. Yes or no? You have to know the conversion factor. Now, if I tell you that $1 is 80 rupees, you have to know this. Only then can you solve this numerical. Yes or no? Hey, why are you people quiet? Yes or no? Does that make sense? Forget about this numerical. I'm talking about this. This is in rupees and this is in dollars. Unless you know the conversion rate, you can. What is the moral of the story? You have to have something which links the two. Unless you have a linking factor, you cannot solve this numerical. So now that's what I'm coming to. You have a sign here. This is rupee and this is dollar. How can you link the two? What is it that links sign with cos?
The hypotenuse.
Sorry, not the hypotenuse. No, you're going wrong. We just talked about some concept today.
Sir, sine O is equal to cos of 90 minus O.
Perfect. That's the one that we ought to use. So unless we have both of these the same, how can we solve? So look at this. How we solve this is, can I write sine 3a as cos of 90 minus 3a? Hey, cos of 90 minus theta is equal to sine theta, and sine of 90 minus theta is equal to cos theta. Didn't we learn this a while ago? There are others as well, but these two didn't we learn? Do you remember?
Yes.
Yes, sir.
Okay, that's exactly what we are doing here. So this becomes how much? This is equal to cos of a minus 26. So cos of something is equal to cos of something. Therefore, can we not conclude that 90 minus 3a is equal to a minus 26? That implies 90 plus 29, a plus 3a. Yes.
Sir, 26 or 29?
Sir,
Sorry.
A minus 26, sir.
Yeah. Right. 26. Sorry. 26. That implies, what do we get? 4a is equal to 116. Therefore, a is equal to 29 is the answer. How many of you have understood? It's not just about solving. We can do it. It's about getting to that Sonu Monu thing. We have to have something common in between them to be able to solve this. And what is that? The complementary angle tool helps over here. Hey, all of you, everyone, is this making sense with every one of you? It must, it should.
Yes, sir.
Let
It's
me
making
know.
sense.
Very good. Let me know if somebody hasn't understood, just in case. That's absolutely okay. It's absolutely okay to not understand. That's absolutely okay. What is not okay is to keep quiet if you have not understood. Please. Let me know once you're good with this. We have a few more problems, numericals, to solve, and we will solve those. So I'll give you a similar numerical to solve. Okay, I'll give you 2 minutes. Let me know. You can turn your pages or, whichever, reference you want to make to solve this. So the question is sec of 4a is equal to cosec a minus 20. Find a. Can you try this? So you have to know the linking, the bridge between sec and cosec, just as we did for sine and cos. Yes, anyone, any luck?
Sir, A is 22.
A is 22. Okay, let's see what others get. Who was that?
Me, Anthony.
Sir,
All
even I
right.
got AS 22.
And who is that?
Sir, Tanvi.
All right.
Sir, A is 22.
A is 22. And who is that?
Arnav.
Enough. All right. Good. So I think you got the knack of it, right? So sec 4a, what is it that links sec and cosec? We know that cosec, this implies what? Cosec of 90 minus 4a. You all agree that this is sec a? We saw that a while ago, right? Cosec of 90 minus theta is sec theta, and sec of 90 minus theta is cosec theta. That gets us cosec of a minus 20. Therefore, 90 minus 4a is equal to a minus 20. What do we get? 90 plus 20 is equal to a plus 4a becomes 5a. Therefore, a is equal to 110 by 5, and that is equal to 22. That's the answer. Good. I have been telling this again and again. I sent in the messages as well. I told you yesterday, trigonometry carries 12 marks. 12 is 15%. Damn, 15% is just too much, isn't it? So I think you have a good start in trigonometry. That's what I would feel. I would say you have a start. I don't know if it's a good start. I mean, it's for you to decide and judge for yourself, but I think you have a start in trigonometry. Don't lose out. Practice this. You know, it's very interesting. And then the next chapter we'll do sometime. That's applications of trigonometry. That's even more interesting. And that is, it is fantastic. Something that, you know, I would do for hours together when I was in school. Not that I was very studious, but I would still do because it was very interesting. So the next one is, this is the question. 9 sec square a minus 9 10 square a is equal to what? The options are A, 1, B, 9, C, 8, D, 10. Before you even think of what to do, the answer is 1. No, that's what I was telling you. That's what I was cautioning you. Before you come to an answer, follow the process. Identify the tool. Is this hair cutting? Should we use hammer? Should we use scissor? Is it a nail? Should we use screwdriver? You have to get that right. Which one will help you? The complementary angle will not work because, you know, this sec and 10 are not related. See, cos and sine, cosec and sec are linked. Here, that doesn't help. So we have to think of some other tool. What tool will help here? I'll write the three identities. Cos square theta plus sine square theta is equal to 1. 1 plus 10 square theta is equal to sec square theta. 1 plus cot square theta is equal to cosec square theta. So first thing, I think I've already given you a clue. It's about the identities. Which identity will help here?
Second one.
The second one. Let's see. So 9, can I not write 1 plus 10 square a here? Minus 9 10 square a. Let's now expand distributive property. 9 plus 9 10 square a minus 9 10 square a. Yes or no? Make sense, all of you? Okay, I think we'll solve one more numerical and then we'll wind up. All right, let me see what else I have. I have just listed some questions here. So, okay, we are done with this. Let me take one. This will be our last question, okay? All right, let me take this last question. Okay, so we have this question, prove that, or no, it's actually a multiple choice again. 1 plus 10 square A by 1 plus cot square A is equal to, and the choices are A, sec square A, B, minus 1, C, cot square A, and D, 10 square A. So the first 1 minute, I think I will let you people think which tool to use, what and how to solve, and then I will solve this for you.
Sir, tan square A. Option D.
Option D. Okay, I don't know. I'll solve and then find out, but I'll see. How about others? Okay, let us understand from you what you people have done. See, there are 4 topics that we have learned, right? I don't have it here, but I had written those 4 topics here. So I think it's not about trigonometric ratios. I think it's a mix rather. So, and then see, it's about, sometimes you use a hammer and also a screwdriver. So once it gets to, so not every problem can be done only by using a hammer. Sometimes you need a mix. So this is actually a mix. Let us see what all we can readily do. So do you all agree that 1 plus 10 square A, there is one identity in this form? We don't even have to maneuver or manipulate or do anything. 1 plus 10 square A is equal to sec square A. We learned that. And I agree that you would not be very familiar, but I'm not asking you people to just be bang on right from now. No, it will need practice, but I hope this is not strange. This is not a stranger for you. We derived this a while ago, sec square. And what was 1 plus cot square A? This was cos sec square A. Good. Now we know that sec square A is what? 1 by cos square A, and cosec is 1 by sin square A. So can this not be written as 1 by cos square A into sin square A by 1? This is dividing, so it multiplies, it becomes reciprocal, right? This is equal to what? Sin square A by cos square A, and this is equal to sin by A is 10, right? 10 square A. So D is the right choice. All right, so you have got a feel of, so in this case, what did we do? We used trigonometric ratios over here to an extent. We also used identities. So you just see how, the dimensions of the numericals will increase. There will be some which will require more than 2 identities or two tools, so, but overall, it's about getting the basics right. At this time, what I would suggest is get the basics right. Spend time on these. I know that you people are still holidaying. Do that. You don't have to start studying like mad from today. Do it, but just keep track. Just keep track. and nail things. Just get into that habit of nailing it. When you have sat for something, nail it, because there are a lot of things in class 10. I'm not trying to scare you, I'm just trying to be realistic. A lot of things, if you keep everything open, it becomes very messy very soon. So try to settle things. You have picked trigonometry, nail it, finish it. Obviously, you'll have to keep revising it. That's another thing. But at least get done with the understanding part of it. All right. So I'll just tell you one very quick thing before we conclude. Or let it be. Let it be. That's another subject. I just wanted to tell you some cool fact, but let it be. I think it's already 11. So all of you, all the very best. I think your results are coming out in a couple of days, right? All the very best. We'll meet again. Probably I'll do some science session, sometime very soon. I also, await your inputs. If you want a certain chapter to be done, probably next week, then you can let me know. Okay. And I will, see the majority view and probably do a chapter. I do maths, physics, and chemistry. All right. So anything across these, any damn thing across this, just tell me and I will try to help you. All right, then that's all for now. Have a wonderful Sunday and thanks for joining all of you. Have fun and we'll catch up again. Take care. Chalo then. Bye all of you.
Yes, sir.
Bye.
Thank you.
Thank
Bye,
you.
sir.
Bye.
Thank you, sir.
Thanks. Thank you. Bye-bye.